Okay, so let's play around with another tensor equation with the lowered indices, the same object. We'll see that we get the rest of Maxwell's equations from this. And so we'll again assume we're in either flat space or whether we're evaluating this locally at in an inertial frame. So this becomes, we'll replace covariant derivative with just a regular derivative. Like that, and then we get to pick the indices. Let's say A equals 0, B equals 1, C equals 2, and that gives us 0 equals F0, 1, comma 2, plus F1, 2, comma 0, plus F2, 0, comma 1. And so we can see, if we're not too careful about the upper and lower, this basically looks like a electric field in the x direction, comma 2, which means derivative with respect to y. This is a magnetic field, right? That's 1, 2, so this is magnetic field 3, in other words, BZ, derivative of that with respect to time, plus derivative of F20 is an EY with respect to the first coordinate, which is x. And so that's equal to 0. And we can see that this is basically the z component, of the curl of the electric field plus dB by dt equals 0. So, well, actually, this is Faraday. I think this is Faraday's law, Faraday's equation. And the other one that I said was Faraday's law was actually Ampere's law. So, but it doesn't matter what they're called. Okay, so then if we use, say, A equals 0, B equals 2, C equals 3, then we get 0 equals, we should get another component, F0, 2, comma 3, plus F2, 3, comma 0, plus F3, 0, comma 2, and so this is a derivative of a y electric field with respect to z, plus this is a magnetic field derivative of a bx, because it's the b1 component, with respect to time, 0, plus derivative of z component of electric field with respect to y equals to 0. We can see that this is the x component, right, because we see it here. We see the x component of this equation, curl of v plus dB by dt equals 0. And we won't bother with the last one that has also a 0 in it. So we'll just do, right, because this is there are 4 possibilities here. And so we have, let's go to the A equals 1, B equals 2, C equals 3. And that gives us new information. So it looks like this, 2, 3, comma 1, plus 3, 1, comma 2. And this is a magnetic field of 3, so BZ with respect to 3, which is Z. This is magnetic field B1, which is X with respect to X, plus a magnetic field 3, 2, which is magnetic field 2, or BY with respect to 2, which is Y. And that clearly is the divergence of B equals 0. So those are the rest of Maxwell's equations.